All right, let's look at another one. I want to make sure I mix in some other variables. They don't have to be x and y, and we should be comfortable with that still. So dv is equal to w plus 2vw dw, just moving the dw over to that side. And then I would like to separate in a way that leaves w's on the right and moves v's to the left. And that's actually not trivial right now. I can't subtract the w without distributing the dw through first. And then if I subtracted that, I'd have dv minus w dw. Not so great for my integrating. So instead, what I want to do is factor. So remember, the key is writing this as a product with only w's in one factor and only v's in the other factor. And that'll leave me with a 1 plus 2v. And that is separable. Not quite separated yet. I did separate it into factors, but the dv and the dw need the v and the w with them. So I do still have to divide over 1 plus 2v. Okay. And then we can integrate. The antiderivative of 1 plus 2v, again, if these get a little tricky and you're worried you're going to make mistakes, you can substitute that out. You would let u equal 1 plus 2v. I also think it's okay to guess and check yourself out of that one at this point. I think I'm going to need a natural log because I have a v to the first power. If I check myself, the derivative of the natural log of the absolute value of 1 plus 2v is going to be, we're going to ignore the absolute value, so 1 over 1 plus 2v, and then the chain rule would give us an extra 2, which we don't want, so I'm going to multiply by 1/2. The antiderivative of w is w squared over 2, and then I'll throw in my plus c. I'm solving for v, and in case you get mixed up, the reason I know I'm solving for v is because this was supposed to be the derivative of v with respect to w. So v is the function, w is the independent variable. Okay, so to solve, I'm going to first multiply by 2. Multiplying our arbitrary constant by 2 doesn't actually change anything. That still means I could add on any real number, and it would be one of my solutions. To get rid of a natural log, I need to exponentiate. And remember, e to the w squared plus c can be written as e to the w squared times e to the c. And this I'm going to call k. Actually, you know what? I'm going to save it up on this one. It's just to show you another option so you don't have to run through so many variables. So I'm just going to say e to the c times e to the w squared for now. And in my head, I'm remembering that that's just a constant right there. Okay, so next step, I'm going to go ahead and get rid of the absolute value. If the absolute value of 1 plus 2v is equal to this e to the c, e to the w squared, then 1 plus 2v either has to be the same as or the opposite of e to the c, e to the w squared. Okay, I'm kind of tempted to change it now, but I think I'm still going to save it because I can see that we're going to divide by 2. So let's subtract 1 from both sides. And then we'll divide everything by 2. And I'm going to say I have v equals plus or minus e to the c, that doesn't look very c-ish, over 2 times e to the w squared minus 1 over 2. So I am splitting up that fraction. Not the end of the world if you don't, but I'm going to. And now I'm going to go ahead and say all this mess right here, I'll just rename it all at once instead of renaming and renaming and renaming. I'm going to call that, what did we do? K. I kind of like the K. And here, K can be any real number except for 0, right? E to the c is going to be a positive number, but we have plus or minus, so we can get negative. Dividing by 2 doesn't change that, but there isn't any way to get 0 as your constant. Okay, thanks for watching.